The Leaning Tower of Pisa was originally perpendicular to the ground and 179 feet tall. Because of sinking into the earth, it now leans at a certain angle theta from the perpendicular. Theta. The building is still 179 feet tall, so let's put that on the picture too. 179 feet tall. That represents like the center line of the building here that I'm drawing. It leans at an angle when the top of the tower is viewed from a point 150 feet from the center of its base. Okay, what the heck are they saying here? We need to go out 150 feet from the center of the base of the tower. That there's an angle of elevation up to the top of the tower of 53 degrees. Approximate the angle theta. This one is challenging because theta is outside the triangle, but we can bring it in. Let me show you how. I'm going to start and give you some good north-south lines here to help us see what's going on. So one of them that's going to go in is here. Come on. No, we're just going to do it by hand. This north-south line is relevant because it is parallel to the other red line in the picture. Notice that the angle theta outside the triangle is part of a parallel lines cut by a transversal situation. So parallel lines shown in red are cut by a diagonal or transversal in blue. Angle theta is congruent to theta here, this angle. We can repeat this process with the other corner of the triangle to parlay that 53 degrees into something useful up here. Let me get you a horizontal line too. Okay. What I'm looking at now is maybe these two horizontal lines cut by a diagonal. 53 degrees here becomes 53 degrees here. This angle is the complement of 53 degrees. What is 90 minus 53? 37 degrees, because this was 53 degrees. So this angle up at the top is theta plus 37 degrees. What I'm going to do now is I'm going to give these angles and sides names. A, B, C. This is now a matter of either law of sines or law of cosines to solve for angle theta over here. I'll go ahead and write it out, but I don't think really much more needs to be said about it.